Okay, my name is Sanjeev Kumar, and first of all, very good morning, good afternoon, and good evening to everybody from wherever you are joining us during this presentation. I'm quite excited to welcome such a diverse group of professionals to this presentation. And the key topic, as it is on the screen, is balancing technical and economical aspects of borehole imaging in geomechanical applications. And of course, I look forward to share some insights and learning also from all of you. So we can discuss in the later stage of the presentation. Yeah, so okay, let us go ahead and dive into this presentation. So moving on to my agenda, basically this agenda is to discuss the technical and economic pillars, couple of applications of borehole imaging in geomechanics that should provide an overview of the technology, including optical, acoustic, and electrical imaging techniques, discussing the cost effective and economic benefits. And also I'm going to highlight a couple of investment with few examples and addressing the innovation and the environmental and safety protocols. Finally, with few of the key takeaways and couple of recommendations. Right. So moving on to this one, the key objective which is in my mind before I gone through this is basically we all are interested here to critically assess and optimize borehole imaging technologies. We are nowadays very extensively using and intensively in fact using this technology within the geomechanical applications and harmonizing a lot of technical excellence in the context of economical viability, right? So couple of the factors which I have gone through while thinking about it is about the technological performance and the feasibility, how we can make it economical viable, and how we can integrate couple of data together and make the strategies, and then we find some kind of innovative solution. And this practices keep on improving or going on with couple of projects. So some of the learning, kind of lesson learned, how we can make the sustainable practice. This is what was in my mind basically. So moving on with these objectives, first of all, I thought basically about the key challenge which we see in the geomechanics context, and we have gone through a couple of literature in past. I think most of us, about 40% of this non-weathered, non-productive time is because of the wellbore instability. So, and that is costing about $1 billion in the case of Gulf of Mexico only. And 70% of this wellbore stability cost is associated within the shales. So that means where we see the overburden, the drilling impact, and the drilling challenges. And also, these conditions become sometimes very challenging. Even nowadays, what we are seeing, the easy formations are becoming very problematic. And at the time of when the depletion started, then we arise these kind of drilling issues more if we don't plan these things properly. So the role of this is to manage the risk, the key role, reducing uncertainty, and the optimizing drilling. All three factors are key for geomechanics. So then, if we think about the workflow for borehole imaging of this one, uh, Peter, I'm on introduction slide actually. Please go back. Yes, thank you. Thank you. So, two key things I thought about for the project planning and design, and how we integrate this data together, means combine the database with the comprehensive analysis. So in project planning stage, we thought about the pre-drilling preparation, means the well location, tool configuration, whether the vendor means intact and all the tools have been tested properly. And also at the same time we also take care about the team training. We learn from so many projects at the same time. So drilling data acquisition, moving on to the second box, in the first row, second box, drilling data acquisition. This is regarding in the operational drilling operation and real-time imaging point, along with the key data collection, and then comprehensive data processing and interpretation, which I mentioned in the third box, in the first column. And the comprehensive image processing is also going to be important in the geomechanical analysis, stress and rock property assessment. And it is now becoming the industry practice that we are really analyzing these images in very comprehensive form. And once we have this, it helps us out in the decision making and the optimizing drilling operations, and the cost benefit analysis we do also consider, right? Then also these all process, this workflow we report, document it for the future use or the current use, and learn from each other. Something like a continuous monitoring and improvement development process. We collect the feedback from each and every well and every drilling things. Okay, moving on to the next. Yes, so some of the technical plus of borehole imaging in geomechanics. We know there are a lot of things means about acoustic imaging. We know a lot of industry standard tool provided by various vendors, either any vendor. A lot of vendors are in the market. So just means in acoustic imaging, the key things we want to detect the fractures and the borehole failures. In electrical imaging, we see the measures of electrical conductivity mainly along the borehole wall, and effective these tools are particularly in the conductive mud environment. You all know about that. But nowadays we are giving a lot of emphasis to these techniques. Optical imaging is identifying the geological features and fractures, and then we go to the data interpretation and analysis that gives the critical insights to locate the fractures, rock properties, and in situ stress conditions. And now in the end, the real-time monitoring is also the key aspects. Real-time data acquisition, and the team is sitting on the in the real-time form in the offices, and it allows for the immediate decision making during the drilling operation. So this is the key things technically we are seeing when even we are monitoring the real-time operations sitting in the office. Please move on next. Yeah, to the economic things from economic pillars of borehole imaging, if we see. So a couple of things we see here: the cost reduction in the form of once we have the productive zones and avoid the non-productive zones. So reducing this drilling cost, and we can minimize the risk of the dry hole, right? This is one of the key part under the cost reduction. Then yes, the increasing recovery rate, that is a more effective extraction strategies we plan, we implement this, and it is also going to lead the higher recovery rates and maximizing the value of hydrocarbon resources, right? In the operational efficiency context, we have the immediate means adjustment during the drilling operations, and that could reduce the downtime and improving the overall operational efficiency. Yeah. The another factor which I see playing the good role in the economics part is the key risk mitigation. Detailed imaging is going to help us in identifying the potential hazards, couple of integrity issues, and also reducing the risk of means costly failures or accidents, these kind of things. The moving on to the next pillar, and is decision making. Yes, we are going to have the decision making in the all scenario, either it is exploration or development or the production activities. The next factor is the extended well life, optimizing the drilling production strategies or borehole imaging technology. It can extend the productive life of the wells that can lead to the long-term economic benefits. So these all factors means need to be addressed when we are going in the form of borehole imaging sense. Moving on to the next, why we need to invest in this technology. So there are a couple of factors yes, of course, in the end, we need the return on investment, whatever we are putting, the efforts, the money. Every company is nowadays very much cost conscious. And yes, of course, we must be, we should be. So in that sense, that couple of points which came to my mind is what it is giving technically, what it is giving economically. Enhanced formation evaluation, yes, imaging is one of the key source. We, as I discussed in the previous one, improved drilling efficiency, no doubt about that. Once we have in geomechanical context the very good control on parameters, we can improve the efficiency. And reservoir characterization, yes, reservoir characterization is also one of the key things. It provides us proper understanding in the structure and the properties of reservoir. That is actually the critical for this resource extraction. The next point was structure identification and analysis. We know our tool are means borehole imaging tool are quite good in identifying and characterizing features. So it, in the end, this gives us a very valuable information, and on their orientation and density. It is very essential for reservoir management and enhancing the hydrocarbon recovery. Then we, considering this, we have a factor called reduced risk. Reduced risk is also when once we have the very good visualization of borehole imaging data, we can make better decisions, informed decisions, and reduce the risk. And so investing, if we see overall, the investing in borehole imaging technology is actually going to lead the increased efficiency or reducing risk and the better decision making in all our subsurface oil and gas operations. So this is what I wanted to highlight. Moving on to the next, with a couple of examples actually I thought about, and one of the example which is inclined to the identifying borehole washouts. So somehow we have seen in my first figure, you can see in the first track I am presenting here caliper which is showing the presence of severe washouts, and the actually the pads could not reach to the borehole wall. We can see in the image itself. Yeah, in the second column of first image, we have seen in the image itself. So these dark voids, basically, these dark voids are clearly showing the increase of borehole size. So moving on to our next one, this is also one of the example here, vertical barrier identification. So we see here we can discriminate the vertical boundaries, which is we could see in the, if we see the processed image in the second column where we have the high resolution image, we clearly see the boundaries here, vertical boundaries, which is showing in the processing part, in the second column, fourth column. And unfortunately I'm not able to put up my mouse, but I'm sure that everybody can recognize this in the second, fourth, and the high resolution image are clearly the indication of boundaries. And in the low intensity layer, in the we can use these low intensity layer separating the reservoir zones. In the bottom of this, I put a line also very clearly, boundary line here. Yeah. So moving on to my third figure, which is showing the identifying borehole washouts. So we can find using this prominent key seats here, and it is in this third picture in the center of these two at the bottom part. Yeah, you can see there are the key seats which is potentially observed in the top and bottom part in this picture, where I am putting one marker in the oval marker, black color marker. So this basically a mechanical weir at the top or the bottom of the hole, and it is leading the asymmetrical notching of the borehole. And out of these three, actually what I see, if we combine all this and these applications, these kind of examples in our various projects, we could clearly see it is going to improve the accuracy, the cost efficiency, and also in the form of enhanced recovery, right? So this is overall very means good understanding of subsurface geology that can lead to optimize the resource extraction and hydrocarbon recovery, combining all this. Yeah, please moving on next to, yeah. So one of the example here I put when we were in the stage of well planning. We had one well in Southeast Asian region, offshore well, and there we were working on the critically on the wellbore stability. Actually, we wanted to deepen the hole, sectioning the section using some pre-drill geomechanical model, and also we wanted to make sure about the mud weight here, so which was actually little bit in a good range, 11.7 to 17.5 ppg, and when we deepen the session there is a chance to get it increase. So it was a these help image helps us a lot actually, showing these showing this scenario where we could find out on the basis of maximum predicted pore pressure, and that was considering as a magnitude of SH min for actual FCP and LOT test from operational well itself. So this data actually help us out even from the offset well, and also we included the regional borehole experience. We could plan the better way. You can see in the picture of left side here, this was without the geomechanical input, and because of exploration scenario, it sometimes become very difficult. So we try to combine all the offset well data at the same time with geomechanical input nearby. So here we get the better control for reducing our controlling our drilling cost and safety point of view, and at the same time the drilling optimization, and later on when we got the tests and all from production point of view. So these benefits actually are means we have observed that these effective well planning and stability management, it significantly reduce the drilling cost, and at the same time the non-productive time, so and avoiding the costly drilling problems. So when we had our KPIs of the well, that help us out this geomechanics study to maintain the KPIs, and means give us a very good outcome. And also from HSE point of view, it enhances the safety also in the part of reducing the risk of blowouts or other drilling hazards. So it has enhanced overall safety in the sense. And from production optimization point of view, we did a proper planning. We set up all the KPIs of the wells in that area, and then the stability management was done very critically. And yes, of course, we had the better reservoir contact and optimized hydrocarbon recovery in the later stages. So this was one of the key things we take out technically and economically by the well planning. Yeah. Okay, moving on to other one. Next slide. Yeah, in the next slide, basically, I was going through one of the study when I was going through this word stress map. So, and I was pretty impressed actually when I went through this paper. So I just thought to address this, and it was basically mentioned on the borehole image logs and the drilling data all together, and we could clearly characterize here in situ stresses and identifying the overpressured formation. Yeah. So when we integrated by integrating this micro resistivity and the acoustic borehole images with drilling data, so the confidence level got really increased, and it was a significant improvement of coverage in this word stress map. So we could see, I put here the reference also, anyone can go ahead and have a look. This was very high quality data of this word stress map, and exploration risk also it could reduce, and optimizing the drilling operations. So basically when we go through our different geographic regions, at least it is a good idea, good benchmark or a kind of basis about the stress conditions, and where you can you can get overpressured formation, you can have better control, I mean to say. This is the reason I thought to put this example. Yeah, moving on to next one. Yeah. So if we see in the from innovation and adoption point of view, yes, driving efficiency is basically in the current scenario, we clearly see the digitalization. And digitalization is something like our nowadays the very enhanced advanced software image processing, these things making interpretation are becoming more faster and accurate. And also now machine learning is also popping up in the same technology. So some of the artificial intelligence algorithms can detect patterns and anomalies that can be missed by human eye, improving the risk assessment. But still, I personally see means machine learning and it is good. AI algorithm is okay, but in the sense still we have to check manually. It will take some time or maybe few years to have better database when we implement in the AI technology. This is what is my personal feeling. But anyway, we will discuss it during Q&A session if somebody would like to. So next is fiber optic technology. That is also a very much emerging method that provides continuous measurements along the borehole, and it offers a very comprehensive understanding of the geomechanical conditions. So somehow, and at the same time, this is also going to provide very valuable insights for optimizing drilling and production operations. So actually, these operations are transforming this whole field of borehole imaging, making it more efficient and accurate, and indeed the cost effective at the same time. Right, moving on to next one, a bit about considering the HSE protocol, environmental issues, means to make the sustainable practices. So when we accurately identify these subsurface conditions, minimize the chances of unintended fluid releases, means sometimes it could be due to leak or equipment failure or drilling through sensitive formation. There are so many possibilities here. So, and then we move on to this enhancing safety. Yes, understanding this stress study, geomechanics really help us out to prevent these catastrophic failures and protecting both personnel and equipment at the same time. So some of the points which I noted here in two boxes. Yes, this reducing environmental risk, when we talk about, we say using the environmental friendly drilling fluid, some environmental impact assessment we do in advance, proper waste management or regulatory compliance. So these regulatory compliance are a couple of times in different countries, different regulatory bodies, so they need some different requirements. So it is always a good idea we go through their requirement in advance, what are their respective governments requirements, their rules and all that. So moving on to the enhanced safety, integrity management is one of the key thing, wellbore integrity, real-time monitoring that gives you better control, and advanced imaging tool, and also that lesson learned, the trainings at the same time we are getting time to time, the moving on to the next project or something. Okay, let's go ahead to next one. Yeah, so if I would like to provide you a couple of means key takeaways, few recommendations. We have observed in the last slides that the comprehensive borehole technology really going to highlight its significant role in the modern geomechanical applications. And these geomechanical applications nowadays, keep coming, and we can use very effectively borehole imaging technology. The other thing is the critical technical pillars that underpin the technology, including high resolution data acquisition and real-time imaging, plays a very key role. The economic pillars emphasize the cost saving, increased recovery rate, production, and risk management. So as I was talking about when investing, why we should invest in this technology. So it brings a substantial return, means your, and couple of examples also showed this very clearly how we can keep balance in technical and economic aspects. Next, the continuous innovation and adoption. It drives the advancement and the enhanced efficiency, ensuring the technology remains means forefront in the geomechanical solutions. And finally, the environment and safety implications of borehole imaging are paramount, no doubt about that. The technology aids in minimizing environmental impact and enhancing the safety of drilling operations that contributes to sustainable and responsible hydrocarbon extraction. So these are the couple of takeaways I took out after this. And the next one I would like to acknowledge my company, KUFPEC, management, and some of my colleagues who helped me out for their support and their my company's permission to present this work, which we recently did in one of our project with the proper planning and setting our KPIs for that well. So that is what. And next thing I'm going to, in the next slide, couple of references which we have gone through, couple of studies which I have gone through, writing all this in a concise form, and just to addressing all this, which is nowadays becoming very important in modern scenario. So that is it. Overall, I can say that borehole technology stands a vital role in geomechanical landscape. It offers completely a synergy of technical excellence and economic viability, and yes, driving the industry forward. That is what I want to say. Thank you so much. And questions are most welcome. Please.
Thank you. Do we have any questions? Sanjeev, let me ask you a question. Do you
Yeah.
see machine learning and artificial intelligence as a replacement or as an aid to your work?
Well, it is actually the aid. It is not replacement. As I mentioned also when I was talking about this slide, I manually check these images. We put a lot of data, the pre-existing data, and we use this technology. But still, I still believe on the well correlation things, the image correlation if we have from different wells. So it will take some time for me, maybe next couple of years. Yeah.
I agree with you. I think it's going to be more than a couple of years before we see the real benefits of AI, but at the moment, it does bring us some aids in our work.
Yeah. As of now, it is aid only. It build up better confidence.
Thank you for showing the world stress map as well. That is often very useful in QCing of image logs, and I've used it many times to help me orient image logs where I've had problems with the orientation, obviously before my current employer, just to help make sure that we have actually got the orientation of image logs correct. So it has more uses than you just suggested as well. So yeah, thanks for showing that.
Yeah, actually, it was very useful when we planned the well. I had critically gone through a couple of areas here. Yeah. And there was a detailed report available on the website. This one means it was very helpful in my case. Thank you.
Thank you. All right, I'm just looking. I don't see any questions online. Does anyone have any questions at all? Yes, I think we have a question from someone at ENI.
Please.
Yeah, thanks. Roberto Berto speaking. I have a question about, probably I put in the thread question, but doesn't matter. My question is related with the fact, do you see in your company experience the possibility to reduce combining Borehole imaging interpretation with other continuous log, for example, advanced sonic log and so on, to reduce in such way the cost related with geomechanical test provided on core, bottom of core, for example, or at the moment you are not confident to reduce coring activity if you make?
Yeah. Okay. Well, great question. Okay. In our company, what we did, we try to get image data as much as possible in the nearby scenario where we wanted to drill. Not only that, and also yes, in the end we also put all the wells together on seismics. I'm not discarding that. Every information is important here. So in our company, when we were planning the KPIs, it was also based on what information we have, what information we need to grab further. So that also helped us out to design our KPIs for a successful job. That is what I can say. So now we are trying to make the benchmark of the different technology, like if we are recording optical or resistivity, where we have conductive scenario. So we are sorting out these things, and we are also in the process of writing the standard, so we can use in our next projects. It is means it helps us a lot, I mean to say.
Okay, thank you.